Hi students, we're now on 12.6, adding and subtracting rational expressions. So, I put a little example up here. Just like you add and subtract fractions, and you learned that you can add the numerator when the denominator is the same, it's the same with rational expressions. Rational expressions are just a fancy word for a much bigger fraction. Instead of having 1/5, you've got a polynomial divided by a polynomial. But the same rules apply. So if I have 1/5 plus 2/5, because they have the same denominator, I can just go ahead and add. And that's all this piece of paper is saying right here. These are the rules here. It's kind of faded, so I write it out. So AC plus BC, because they both have C's, you just add the top, the same with subtraction. So I'm going to go ahead and do it on a piece of paper so it's not all cramped. And we're going to start very basic. So 5 divided by 3x plus 7 divided by 3x. Okay, the fact that they have the same denominator means it's going to be over 3x, and I'm going to add 5 plus 7, which is 12. So it seems real simple, but hopefully you wouldn't keep your answer like that, because if it was out of 5, I would give you 3 out of 5, but you would not get 5 out of 5 because you can simplify. So if you're going to simplify, 3 divided into 12 is 4, and it's going to simplify down to 4 over x. And so circle or box it in, however, mine looks a bit wonky, but always go ahead and circle box in your final answer so I can see. So now we're going to do subtraction. So subtraction, you just have to be careful, because if you do not change the sign after the subtraction sign, then you're not going to get the correct answer. So again, x minus 1 is the denominator. So it's going to be over x minus 1 right now. But this is where you have to be careful. I have a minus, and in algebra, anytime you have a minus, that means all the signs change after. It's like multiplying by a -1. You're changing everything, okay? So you've got minus x, which the x was positive, but now you put the minus in front of it, it's now becomes a negative x. Just like the plus 5 now is going to become a negative 5. So I'm going to write that out. So 3x minus x minus 5. So 3x minus x is 2x minus 5 over x minus 1. And that is your final answer. Nothing else will simplify. So just remember, with addition, it's real easy. When you have the subtraction, if you'll change the sign, then you'll be fine. That's the biggest thing between the two of them. So that seems pretty straightforward when they have the same denominator. So we're going to have to do something now, because obviously we're not going to add all the fractions with the same denominator. We're going to be adding fractions with unlike denominators. So to do that, we have to find the LCD. So I'm just going to give you a real quick example of one that's very basic. So say I have 1/5 plus 1/3. Okay, so just going back to the basic rules that you're used to seeing. Can you add these together? Hopefully you remember how to do fractions. You can. You have to get a common denominator, or an LCD they call it, lowest common denominator. I just call it common denominator, meaning that. They call it the LCD, okay, lowest common denominator. So the lowest number that 5 and 3 both go into is 15, okay? So the lowest common denominator would be 15, all right? So then you would have to change 1 over 5 to a fraction out of 15, and you would have to change 1/3 to a fraction out of 15 too. And then you can add them together because they have the same denominator. Or you do the same thing. So we're just going to practice right now finding the lowest common denominator. So here we have 1 over 4r and r plus 3 over 10r squared, okay? So what we're looking at is the 4r and the 10r squared, and we need to find the lowest common denominator. That's all we're doing right now before we actually add them together. So what's the smallest number that 4 and 10 go into? So hopefully you would understand that it's 20, and I think most of you would. So you have to be able to do that with the number. Now the variables are real easy. You have to take the biggest one, okay? You can't take the smallest one because r squared can't go into r, but r can go into r squared. So the LCD is 20r squared, okay? So that's how we start. Because if you can't find the LCD, then you can't change fractions to add them together. So let's do another one, okay? Because they're going to get a little bit more to them. But if you understand this process, then you're going to be fine. So there's the first fraction, 5 over x minus 3 to the second power. That means there's 2 of them. And 3x plus 4 over x squared minus x minus 6. Okay, so I have to factor this or I won't be able to tell. So I'm going to go ahead and factor, and that's going to give me x and x. The minus here tells me that they're opposite signs, and I need to make a 1, so it can only be 3 and 2. 3 times 2 give me 6, and 3 and 2 can give me a 1, and I need a negative 1. So it has to be negative 3 plus 2. Okay? So from here, I'm going to write it here so you understand. So the first one is x minus 3 squared. It means I have 2 of them. And then this one has x plus 2 and x minus 3. Okay, so we have to include everything for the LCD. So just like you have an r, so it's actually good here, I have it here. You've got an r and an r squared. You would pick the r squared, right, because it's bigger. So I've got 1 x minus 1, or I've got 2 of them. Which one are we going to do? Hopefully you're going to tell me we're going to do the one with 2 of them, okay? Because 2 of them will cover that one, but it won't work the other way around. So x minus 3 to the second power is part of the LCD, so that takes care of this. And then we have to include the x plus 2 because everything has to be included, okay? You will not find the LCD or lowest common denominator if you do not include the x plus 2. So right now, all we're doing is practicing that. It's huge because if you understand that, then we're going to be able to add fractions with unlike denominators, all right? So let's try find one more. So here we go. 3 over c minus 2, comma, c plus 8 over 2c plus 7. All right, so let me go ahead and move this down here. Okay, so I'm looking here. I've got a c. I'm just going to write it here, c minus 2, and a 2c plus 7. So we can't take anything out. They're not the same at all. So the LCD is c minus 2, parentheses, and 2c plus 7. We've got to include everything. That includes this denominator and this denominator. Okay, so hopefully you're starting to get the hang of this. All right, I'm going to do one more. I always have extra examples, teachers' examples. Let's try one more and see. Let me push this up a little bit. Okay, I've got 1 over 28m, comma, m plus 1 over 7m cubed. Okay, so I'm looking here. I've got this denominator and this one. I've got 7 and a 28. So which one is it going to be? You know that 7 goes into 28, so 28 is going to be part of the LCD. I've got 1m and 3m's. So again, you just take the one with the highest exponent. So that should be fairly easy to see that the LCD is going to be 28m cubed. Okay, so you have to understand this if we're going to add and subtract. So now we're going to start adding expressions with unlike denominators. So I'm going to go ahead and flip this over. And we're going to start with an example. So here we go. 9 over 8 x squared plus 5 over 12 x cubed. Okay? So the most important thing, and you're almost 50% of the way there, is finding the correct LCD. If you do that, then adding them together is going to be super easy. So I'm going to look at the numbers. I've got an 8 and a 12. So that's what we're looking at. So what's the smallest number that they both go into? Okay, so 8 does not go into 12, and it has to be bigger than 12. So what I do is say, okay, it's not 12. 12 times 2 is 24. Does 8 go into 24? Yes, it does. So I know it's 24. All right. Then I've got x to the second power and x to the third power. So I know that x to the third is the biggest one. So I find my LCD. Okay. And right now, I'm going to change both of them. That's how we're going to add them together. So watch how I do it. It's the same process as when you're adding 1/5 plus 1/3, except for you've got a little bit more. So I have to change this fraction from 9 over 8 x squared to make it over 24x cubed. And then I've got to change this one to make it 24x cubed so that I can add them together. So I look at this first one. So 8 times what gives me 24? Now you should say 3. So that means you're going to multiply, that's multiplication, the top and the bottom by 3, correct? Then I look here, I've got x cubed. Here I've got x squared. So what am I missing to make it an x cubed? You should hopefully tell me that you're going to multiply it by an x. So when I do that, I'm going to take this, and I should get 24x cubed. And if I do, it's correct. So 3 times 8 is 24. X times x squared means it's x cubed. So it's correct. Now the numerator is going to change. 3x times 9 is going to be 27x. So the first fraction becomes 27x over 24x cubed. Now I'm adding 5, 12x cubed. I need it to become 24x cubed. So 12 times what gives me 24? It's all about understanding multiplication. 2. So I have to multiply top and bottom by 2. I have x cubed, and I have it here. So do I need to multiply by any more x's? You should tell me no. All right, so I test here. 2 times 12 is 24, and I've got x cubed, so this is exactly what it should be here. So then I just multiply 2 times 5, which is 10. Okay, so now I want to go ahead and write it as one fraction. So on top, I've got 27x plus 10 divided by 24x cubed. So you end up putting it together like that, and that is your final answer when you add that polynomial to the other polynomial. All right, so now we're going to do a subtraction. It's just going to take practice. If you go real slow and you do it in an ordered way, then you'll be fine. You don't want to skip steps or rush through it. So let's go ahead and do this. 10 divided by 3x minus 7x divided by x plus 2. Okay, so remember, after this minus, that means this is going to change signs, and we'll get to that in a minute. But I've got to look here, I've got a 3x, and I've got the term x plus 2. So what's my LCD? Hopefully you're going to tell me it's 3x and x plus 2. So this is different than that, so that's why I put a parenthesis, and it's going to be over that. That's what's going to include the LCD, the lowest common denominator. All right, so just having numbers now, we have terms and monomials and things like that, but it's still the same concept. So I look at the first fraction, that's why I write it exactly like this. I say 10 over 3x, I have the 3x. What am I missing? Well, you're missing the x plus 2. So you've got to multiply top and bottom by the term x plus 2. Now really, I've done the bottom, it's here, okay? So I'm not worried about that, I just check that when I multiply them together I get that. So now I have to multiply this. It's the numerator that is going to do the huge change, right? X times 10 is 10x, and then 2 times 10, so you're multiplying as 20. Okay, so I'm going to keep this one all over here, all right? So now I'm looking at the second fraction. I've got minus 7x over x plus 2. So again, I look here. I've got the x plus 2. If you do this and understand what I'm doing, then you can understand and do it much quicker. So I am missing 3x. That means I have to multiply this top and bottom, the top and bottom by 3x. Okay, so the bottom's already done. We can see that we're getting that. That's the whole point. The bottom's done. But now you have to be careful because it's not 7x times 3x. It's minus a 7x times 3x, which is minus 21x squared. So it's all about remembering the rules of exponents. So that's good, but you don't want to leave it like that. You want to put it in the correct order. So to make it look nice, I'm going to say negative 21x squared plus 10x plus 20 divided by 3x and x plus 2, and this is your final answer, simplified down. Okay? All right, so we're going to move on, and we are still going to do some subtraction. Subtraction is always the one that takes a little bit more practice than the addition. But if you remember to change your sign, you're going to be good to go. So let's try one that's got a lot more to it. So x plus 4 divided by x squared plus 3x minus 10, subtract x minus 1 over x squared plus 2x minus 8. All right, so we're subtracting one polynomial from another. So again, before you do anything, you've got to find the lowest common denominator, just like you would if you're adding 2/5 plus 3/8. You've got to find the denominator. Same thing here. So you should be able to look at this and see that it's going to factor and this too. So that's what we're going to do here. We're going to factor. So x and x, the minus here tells me opposite signs. 5 and 2 give me 10 and also will give me a 3. I need a plus 3. So plus 5 minus 2. And on this one, x and x, 8 is going to be 4 and 2 to give me 2. And again, opposite signs, a plus 4 and a minus 2. So you've got to make sure that you can factor this. So now, that's good. Yeah, you're about 20% of the way there. You have to get the LCD. You get this, and then it becomes super easy. So I'm going to write it here underneath. Okay, so I've got an x minus 2 and an x minus 2 here. So it's the same thing. So I'm going to use x minus 2. If you want, you can cancel them out after you use. I need to do the x plus 5. I've used that, and the x plus 4. You need to use everything to get the full LCD. Otherwise, you can't combine the two terms together if you do not include from the first fraction and the second fraction. So I always do this because then I look at the first fraction and I say it has the x minus 2 it has the x plus 5, but it is missing the x plus 4. That means I've got to take this x plus 4 and multiply by another x plus 4. You're multiplying. So x plus 4 times x plus 4, that's FOILing. So do it up here. Again, you must probably need a bunch of room to do this. X times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. Okay? And you should be able to look at this and know that this is going to simplify because you can add these together. So you get x squared plus 8x plus 16. That's just from the first fraction. Okay? Then you look at this fraction. It's got the x minus 2 and the x plus 4. I have to multiply by x plus 5. Okay? That's what's missing. So this is where we're going to be careful. There is a minus, and I'm going to leave that out here. I'm going to apply the minus sign to everything at the end. But then what I have to do is FOIL x minus 1 times x plus 5. So I'm going to write it here. And you see, I'm real careful. I've kept the minus right outside here. And at the end, I'm going to distribute a negative to all the signs, but not right now. So I'll bring the minus here. This becomes x squared plus 5x, inside terms minus x, minus 1 times 5 is minus 5. So I have a negative on the outside, x squared, 5x minus x is 4x, and then minus 5. Okay, do you see how I've simplified everything in here? I FOILed it. So now the last thing is I take this is like having a negative 1, and I'm going to change all the signs. So this is going to be a negative x squared. Now I'm going to write it here. Instead of plus 4x, it's minus 4x. Instead of minus 5, it's plus 5. Okay, so now to simplify, we look here. X squared and minus x squared, they're going to cancel. 8x minus 4x is 4x. Okay, once I'm done, I just put my pencil through, meaning I've used the x's and I don't get confused. 16 plus 5, that is plus 21, all over x minus 2, x plus 5, and x plus 4. That is the final answer when you subtract. Or if you were to add, the biggest thing with the subtraction is don't forget that negative sign. That's what's going to change everything. Okay? So you're just going to have to practice. And the more you practice, the better you're going to get. I'm going to do one more here. Y over y plus 1. I'm going to go ahead and move this down. Y over y plus 1 plus 3 over y plus 2. This one isn't too bad. It's not a huge polynomial. So we can't add them together because they don't have the same denominator. You should be able to look and say the denominator is y plus 1 and y plus 2. It's going to be all over that. Then you look at this. It has this. It's missing y plus 2. That means top and bottom get multiplied. But you can see the bottom's already done. Once you understand that, you don't have to keep doing the top and bottom. But I'm doing it to show you. You're really interested in the top because you've already done the bottom, looking here at the beginning. So y times y is y squared. 2 times y is 2y. Now I look at this fraction. I've got a y plus 2. I need to multiply by y plus 1. And again, I'm showing you the bottom, even though I've done the bottom. But really now I'm interested in the top. 3 times y is 3y. 3 times 1 is 3. So now let's just simplify. I've got y squared plus 5y plus 3 over y plus 1 and y plus 2. Okay? Final answer. So you're just going to have to practice and do it the way I did. There was no minus sign here, so that's easier when it's an addition. When it's a subtraction, don't forget to change the signs. Okay, guys, just work and keep on working. We're almost at the end, okay? You're doing a good job.